Hello, my name is Samba Wassenberg from the University of Antwerp. I'm a biology professor specialized in the study of the mechanics of animals. And together with my colleagues from the University of British Columbia in Vancouver and from the Natural History Museum in Paris, we tested the hypothesis whether woodpeckers absorb the shock during impact with the tree to protect their brains from getting damaged. This hypothesis is very often presented as a fact in popular scientific works like books and newspapers, on information panels in zoos, and also engineers have already used woodpeckers as a source of inspiration to design shock-absorbing materials and helmets. The prime candidate of a potential shock absorber is the zone of spongy bone located between the beak and the brain in woodpeckers. But there is still no evidence that shock absorption is occurring in this zone or some other part of the head. There are even reasons to expect that woodpeckers actually avoid shock absorption. We can all agree that this is a decent hammer that can efficiently be used to transfer its kinetic energy into a local deformation of the tree. But a hammer with a shock absorber built into it is simply a bad hammer. So how could natural selection have evolved shock absorption in a woodpecker if this would impair the bird's pecking performance? To test this, we recorded high-speed videos of 3 species of woodpeckers: the black woodpecker, the pileated woodpecker, and the great spotted woodpecker. We used these videos to track landmarks on the beak and head. The question was whether sudden impact deceleration of the brain case is reduced compared to the deceleration of the impacting element, the beak. This was clearly not the case, so woodpecker heads function as stiff hammers during pecking, not as shock absorbers. Computer models came to the same conclusion. A shock-absorbing head should hit the tree with increased velocity to do the same work on the tree. And this would eventually result in equally strong impact decelerations of the brain for the birds to complete the same task. But if there is no shock absorption, then how do these birds protect their brains from getting damaged? The second set of model simulations showed that even the hardest hits of more than 100 pecks that were analyzed should still be harmless for the brain. The impact loading on the woodpecker's brain is considerably lower than when a human would suffer concussion. The biomechanical models showed that the built-in shock absorber is just a waste of precious energy for the bird. To be adapted to its way of life, woodpeckers should minimize the cranial absorption of shocks. And this is exactly what we found in the video analysis.